Okay, so like I said, make sure your calculators are in degree mode, but guys, this is not a calculator question, and we're gonna see a lot of calculator, not calculator like we did last semester. This one would be a not calculator question, but those are your two special right triangles, your 45, 45, 90, and your 30, 60, 90. Well, one of the things we have to remember is what goes with what. Remember, 45 degrees is the same thing as pi over 4. 30 degrees is the same thing as pi over 6. And 60 degrees is the same thing as pi over 3. So that'll help us a little bit about which angle we're supposed to be looking at. So for example, on this first one that says sine of pi over 3, we'd be focused on our pi over 3 or our 60 degrees. Sine is your opposite over your hypotenuse, so it'd be the square root of 3 over 2, square root of 3 over 2. So then we would go to our next one, cosine of pi over 4. Pi over 4 is your 45 degrees. Cosine is your adjacent over your hypotenuse. So it would be, well, it would start out as 1 over the square root of 2, which we'll always rationalize here. And so that ends up being square root of 2 over 2. Minus, and then our last one here is our tangent of pi over 4. So still focusing on our pi over 4, but tangent is opposite over adjacent, 1 over 1. So minus 1 there. Now let's talk about this part right here. Those are fractions, and when we're dealing with fractions, remember you just multiply straight across the top, straight across the bottom. Because the 3 and the 2 here are both inside, we can multiply those together and get square root of 6. Multiplying straight across the bottom, 2 times 2 is 4. And you're welcome to just leave it as square root of 6 over 4 minus 1. If you were to put those together, you would have to get a common denominator. So if I were to put those together, I would have to get a common denominator by multiplying this one by 4, top and bottom, and it would actually end up being square root of 6 minus 4 over 4 because common denominator, okay? If you have questions over this type of problem, we will practice it again on Friday, but make sure that you can look at these models, know which angle to be looking at, and answer some questions. All right, today we are focusing on the second half of section 4.3, which is really seeing these trig functions to help us answer questions about story problems. Angle of elevation, angle of depression will show up as vocab words, but also just story problems involving right triangles to apply what we've learned. So let's talk about those two vocab phrases for just a second here, angle of elevation and angle of depression. Both of these, you'll notice as we read, these are referring to this horizontal line, and that's a very big important key when talking about angle of elevation and angle of depression, is that one side of those angles has to be a horizontal line. When it is the word elevation, angle of elevation, you will have one side being the horizontal line and elevate, so you will go up from that line to get an angle of elevation. So your horizontal would be the bottom side of that angle if we're talking an angle of elevation. When it switches to being an angle of depression, you still have that horizontal line as part of your angle, but from that horizontal line, you will head down to form an angle of depression, usually looking down at an object from some certain height is when we end up with an angle of depression. Now, at the end of our notes, we're going to kind of talk about the connection between angle of elevation and angle of depression. Angle of depression, I always think that drawing those triangles is a little bit trickier because our natural instinct is to draw a right triangle like this, which you can do with an angle of depression problem. We're just going to talk about some options here. You will then pick the option that is best for you. Okay, but angle of elevation, angle of depression, same thing from a horizontal. It's just which direction we're headed from that. Not all of our story problems will involve those phrases. Some of them will as we get going through here, but just so we can start out with those vocab. Okay, so first situation. It says, a tree that is 21 meters tall casts a shadow of 25 meters long. Find the angle of elevation to the sun to the nearest degree. Sometimes the drawing of this picture, which we nicely have a picture to look off of here, but sometimes drawing it is the hardest part. So label those things for yourself. If we didn't have a picture, you can draw in a tree or just draw a straight line and call it tree. Okay. We have a picture, so I'm going to go ahead and draw it on here. They say that that one is 21 meters tall. So that side of our triangle is 21 meters. Now, I know this sounds silly, but a lot of people don't know where the shadow is located. If you think about visualizing your shadow, if you're just standing on a sidewalk, the sun's hitting you, your shadow, you would look at the ground. Your shadow is going to be along the ground here. So this is our shadow. And they tell us that our shadow is 25 meters long. When it says find the angle of elevation of these lines, we've got a vertical line, we've got a horizontal line. Your angle of elevation must involve a horizontal line. So it has to go from that horizontal line up to complete the triangle. So here's our right triangle. If I had then color in that last line there. But your angle of elevation has to go, which is why they put the theta down there. There's always a little bit of a question. And again, I know they kind of helped us draw this one, but angle of elevation must involve a horizontal line, which is our shadow along the ground. So it goes from that horizontal line up. That's how I know what angle I'm finding in this one. So once we have the picture drawn, it's really moving back to what we talked about yesterday. And so now my thought process goes to SOHCAHTOA. I look at my picture and I say, okay, if this is the angle we're finding, from that angle, 21 would be opposite, 25 would be adjacent, and the trig function that uses opposite and adjacent would be tangent. And so that's how I know what to write my equation as. So that is how I start my equation. Tangent, my unknown, what we're trying to find is theta. So I'll fill in a theta there. Equals opposite over adjacent. Follow my SOHCAHTOA, opposite over adjacent. And this is what we learned, and this was we kind of sped through this at the end of our notes yesterday, but we had tangent of theta. If I want to solve for theta, it's this tangent part that I need to get out of there, which as I move it to the other side becomes the inverse tangent as I move it to the other side. And then we type in inverse tangent, 21 divided by 25. Into our calculators. Okay, and as I type that in my calculator, let me grab my calculator. So I hit my second key, tangent 21 divided by 25. And I get 40.03025, etc. But they did ask me to round this to my nearest degree, which indicates my nearest whole number. And so I would say that theta is 40 degrees. So that kind of gives you a preview into what we're looking at. Just a couple examples like this of how words can explain to us. And again, a lot of our pictures are kind of given to us, but we could build that too. And then when we build them, I would strongly suggest labeling the sides of your triangle to kind of help you visualize what you're drawing. All right, let's look at our second example here. It says a surveyor took measurements of a lake as shown in the picture. The distance across the lake, which would be this side right here, labeled as A, is unknown. So that's going to be what we're solving for. Use the given measurements to find the distance across the lake. They give us a 750 yards from A to C. And then they give us this angle here is 24 degrees. And so from that angle, again, we think through our SOHCAHTOA. We've got a 24 degrees here. A would be opposite of that. 750 would be adjacent. And so it looks like as we think through SOHCAHTOA, As I scan through and find the one that uses opposite and adjacent, it again tells me that I would be writing this one as a tangent problem. Tangent uses opposite and adjacent. So I would set up the tangent of my angle. This time I know the angle. So I'm going to fill that in here, 24 degrees equals opposite over adjacent. And so we just need to remember our process. Am I multiplying or dividing on this one? And as always with your fractions, start by multiplying by what's in the bottom, and that's going to be our only step needed on this one. So now in my calculator, I'm typing in 750 times tangent of 24. And I get 333.9215, which they said they didn't say. So they're typically rounding to the nearest whole number. So we're going to say 334, what is this, yards. Okay, we do have another example here to talk about that involves an angle of depression problem. But before we get into our angle of depression, I want to have a conversation about giving you options to create an angle of depression picture. And so one of those things is a little bit of a trip back to geometry when we dealt with parallel lines. Back in geometry, you had this whole chapter that was if parallel, then alternate interior angles are congruent. If parallel, then alternate exterior angles are congruent. You remember all of those rules? If parallel, then consecutive interior angles are supplementary. Well, what it turns out as, if I were to look at this as my horizontal line looking down, this is called an angle of depression, right? So if I were to use words to describe this picture, I can say we've got an angle of depression as the bird is looking down at the kitten. But if I were to describe it the other way, what if the kitten was the one looking up at the bird? Well, it's got a horizontal line coming out of its eyes as well. And if it's the kitten looking up at the bird, we would actually refer to that as the angle of elevation. Okay, well, if I go back to geometry, those two horizontal lines, all horizontal lines, are parallel to each other. And so if I were to consider the relationship between the angle of depression from the bird compared to the angle of elevation from the kitten, it would be that they are alternate interior angles. And what we learned back in geometry is that alternate interior angles are congruent to each other or the same. And so that will allow us to kind of flip the picture to being an angle of depression picture from the top to instead being an angle of elevation picture from the bottom. And I'll give you my reasoning for that is that we'd naturally, if I asked you to draw a right triangle, I bet most of us would draw a right triangle like this, with that right angle in the bottom right-hand corner, or maybe on the left-hand corner, or maybe the right-hand corner. But very rarely would we draw our right triangle like this. It's not as natural. And so we can do all this. And again, as we're going forward, I'll give you options here about how to create our picture. But I'm going to utilize the alternate interior angles and draw my triangle a little more naturally for me. Okay, so let me show you exactly what I'm talking about with this next example. It says, from the top of a lighthouse, here's my lighthouse, that is 210 feet high. The angle of depression of a boat is 27 degrees. Now, it is most natural for me to connect the lighthouse to the boat like this, with this line looking down, okay? But if I do this, none of these angles are an angle of depression. This angle up here is not an angle of depression. It doesn't have a horizontal line. This angle down here goes from a horizontal line up, which would make it an angle of elevation. And so if I'm supposed to be drawing an angle of depression from the top looking down, what I would have to do is have a horizontal line coming out of the top of my lighthouse, which I can do. here, and now the angle here is my angle of depression, but that is not inside the triangle that I would naturally draw of the lighthouse and the boat. So I can do one of two things. I could then just use the picture I have with the red and complete my triangle so that it would look this way and use that red dotted triangle as my triangle, knowing then that this is a side of 210. My other option is what I was talking about on the last page. Okay, so if my angle of depression from the top is 27, that means that its alternate interior angle, my angle of elevation from the bottom, is also 27 degrees. The mistake people make is that they draw this picture with the triangle this direction. They hear the word depression, and so they say, okay, looking down from the top, it's 27 degrees up here. That is incorrect. This is not an angle of elevation or an angle of depression. It does not have a horizontal line. Don't do that. Okay, you cannot, we will actually probably hardly ever have an angle up here. Okay, so going back to our picture, it doesn't matter which way you pick. I'm going to go with the blue. But it says find the distance, because again, it's more natural for me to mark down here, the distance from the boat to the foot of the lighthouse. And so this is our question mark. If you were to do this in the red, I would have had to understand that that's that side of the triangle. Now, it doesn't matter which one you pick, because as we look at this, from the 27, we have a side opposite and we have a side adjacent. And again, now I think through my SOHCAHTOA, and from SOHCAHTOA, I pick the side that I pick the trig function that uses opposite and adjacent to tell me how to write my equation. Tangent of my angle, which I know is 27, equals opposite over adjacent. So nicely, we have an example of one with a variable in the bottom. If you'll remember from our last lesson, we went through the long algebra of how to do this and then saw that it's kind of a little bit of a shortcut, that the tangent of 27 and the x kind of look like they just flip-flop spots, and that x is going to equal 210 divided by tangent of 27. So let's go type that in our calculator. And again, I'm going to just go ahead and round this to the nearest whole number. I got 412.41482, blah, 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 which would be approximately 412 feet. As always, as I'm going through this, or if I flip through something too quickly or you have questions, please put those in the chat or unmute yourself and talk to me, and we can cover things more. All right, guys, I've got one last example for us today. Our last example here, sighting the top of a building, a surveyor measures the angle of elevation to be 22 degrees. So we now know that when they're talking about this angle of elevation, it involves a horizontal line and moving up. So we can see that that's this angle. Let me zoom in a little bit here. That's this angle right here, 22 degrees from that horizontal line up. The transit, and I know that's not really something that I would expect you to know, but they have it drawn here in the picture. You see where it says transit. The transit is the piece of equipment that they're using, is 5 feet above the ground and 300 feet from the building. Find the building's height. So I want to look over here to the right-hand side. Notice that we've got the height kind of made up a difference between A, which is referring to from the horizontal up, compared to the height. And so eventually we're supposed to find the height of our building, and our height looks like it's made up of the height of the building plus this little piece down here, which is our 5-foot transit. So eventually I'm going to say that our height is that 5 feet that the transit is above the ground plus whatever we find, which they have marked as A, as the height of the building. So then looking at this again, we start with, okay, let's look at this triangle that they have drawn in here. And so from the 22 degrees, which is the angle they give us, we have to identify our opposite, adjacent, and hypotenuse. Our opposite is going to be, or sorry, A is going to be opposite. 300 feet is adjacent to that 22 degrees. So again, I think through my SOHCAHTOA, and you might be thinking, man, we've used tangent a lot today. And we have. And I'll tell you right now that in real world situations, tangent ends up being used a lot because typically vertical and horizontal lines are easier to find in real world situations, and the hypotenuse is not always. But that's why you'll notice that on these like story problems that we tend to have kind of a unbalanced overuse of tangent, because a lot of times you can find the vertical and the horizontal a lot easier than the hypotenuse, the angled distance. And so you'll notice that it is not unusual for tangent to be the function we use. We know the angle is 22. Opposite would be A. Adjacent is 300. Solve for A. So I'm going to multiply both sides by 300. Typing in my calculator right now. 300 times the tangent of 22. I'm going to round to my nearest whole foot just because that's what they tend to do. And I find out that A is 121. So I'm going to go put this up here and find the height of our building. H equals 5 plus 121, or the height of the building is 126 feet. All right. Today we are going to do the check for understanding, and just like we've done before, go ahead and put your answer into the chat when I get there. When you get a yes, you are correct, you are welcome to leave. Your assignment is homework number 2, 4.3, day 2 on my math lab today.